Greetings, parasite ecologists. We've talked about the phylum Platyhelminthes and the phylum Nematoda. Now we'll discuss the phylum Arthropoda, one of the 4 great parasitic groups that we learned about early in this video series. They say that arthropods run the world, and I think there's an argument to be made for that. The arthropods are quite abundant and speciose. In the phylum Arthropoda, we're going to be talking about 3 different classes. The first is the class Arachnida, which includes the ticks and the mites. The class Insecta includes the lice, true bugs, fleas, and flies. And then the class Crustacea includes crabs and copepods. In each of these groups, there are parasitic members and non-parasitic members. Unlike in many classes of the phylum Platyhelminthes, we don't have 100% parasitism across the board here in the phylum Arthropoda. Parasitism has evolved independently a number of times among the arthropods, and there are a bunch of different lineages of parasites within each of these classes. Here are some distinguishing traits of the arthropods, whether or not they're parasitic. They have bilateral or left-right symmetry, a segmented body, a hard exoskeleton. Their legs are jointed, and that's actually what the name means. Arthropoda means jointed leg. And they have many pairs of limbs. So now we've moved from things that are wormy into things that have legs, different kinds of creepy crawlies. There are 3 things that I want to cover in the next set of videos. The first is thinking about arthropods as being parasites themselves. So first we'll talk about some arthropods that are ectoparasitic. It's rare to find endoparasitic arthropods. They do exist, but there are comparatively fewer of them. We're then going to talk about the arthropods that are Protelean parasites, or parasites that are parasitic only in their larval stage, and then as adults, they're free-living. We've already seen an example of this among the Ficampiids in the phylum Platyhelminthes, and now we'll see a couple of examples of it among the arthropods. And then finally, we'll talk about arthropods as vectors, or organisms that actively move parasites from one host to the next, the way a tick moves the Lyme disease bacterium from a mouse host to a human host, or the way a mosquito moves a malaria protozoan from one human to the next. Recall that organisms that take meals from a number of different prey without killing those prey are called micropredators, and because of the way that they feed, micropredators are really good at being vectors of other parasites, as we'll see. Arthropods play a huge role in transmitting nematode parasites. Why are the nematodes coming up in a lecture on arthropods? Well, because I want you to remember that a number of nematode parasites are vector transmitted. Many of the filarial nematodes have a vector or a host that actively infects the next host, usually by injection. And typically these vectors are arthropods. You'll remember that Wuchereria bancrofti is vectored by mosquitoes, Onchocercovolvulus by black flies, Loa loa by deer flies, and Dirofilaria immitis by mosquitoes. Different kinds of arthropods, all essentially accomplishing the same thing of moving parasites from one host to another host through active injection. Now recall that Dracunculus medinensis has an arthropod intermediate host, a copepod. But that copepod is not a vector because it is not actively infecting the next host by a bite. It is being consumed by the vertebrate host, usually accidentally swallowed in water. Before we dive into the arthropods, I want you to consider one really important question, and that is, why are arthropods as successful as they are? The phylum Arthropoda is the most numerous phylum that exists on Earth, and that's both in terms of the species diversity, or the number of species represented in that phylum, and also in terms of the abundance of individuals within each of those species. We might also argue that arthropods have an outsized economic impact on the world, either as pollinators, pests, or vectors of parasites for people. It raises this really interesting question for me, which is, what is it about arthropods that makes them such a successful radiation of animals? The biologist J.B.S. Haldane once wrote, "If there is a creator, he must have an inordinate fondness for beetles." And of course, that's the guess that anyone would make looking at the diversity of life. How else would you explain the fact that there are 350,000 species of beetles on Earth? God must love beetles quite a bit. But it's not just the free-living arthropods that are successful. There's also an extremely diverse array of parasitic arthropods. So as you view the next few videos about arthropods, I want you to ponder this question. What accounts for the success of the arthropods? Why are they so diverse, both for the free-living arthropods and for the parasitic arthropods? I'll see you in the next video.